Today we're unlocking an engineering secret hidden inside a common garden ladybug. Let's get into it.
Okay, so here's a classic designer's dilemma. How do you get big and strong and small and compact?
Well, our answer is usually, complicated stuff. Motors, hinges, things that break.
But a tiny little ladybug, turns out it found a much, much smarter way to do it.
Here's the challenge. Fold tiny, deploy instantly, and then be totally rigid once it's open. It's tough.
The Ladybug solution? It's all about clever geometry, not brute force, and it uses zero power.
The secret here is stored elastic energy. That's what makes the wing both flexible and strong.
So this all comes down to something called the tape spring principle. Let's dig into that.
You know how a carpenter's tape measure just snaps straight? That's the exact same idea here.
And folding it up is just as cool. The outer shell just presses it all down perfectly.
Get this whole thing uses zero external power. No motors, no hydraulics, just geometry.
So this isn't just a fun fact. It's becoming a whole new design mandate for engineers.
Basically, it's about making things that are super stable in two different states, open and closed.
Think about that ratio, 4:1. That kind of compactness could solve massive problems for us.
And when you compare it to our old methods, well, nature's approach is just way, way better.
Okay, so why should you care? Well, let's look at where this is being used right now.
We're talking deployable solar panels in space, folding robots, even stuff you might use every day.
And this really sums it all up. You don't need complicated machines for complex tasks.
It's a huge shift in thinking. We're not just building parts, we're designing actual transformations.
So it makes you wonder, right? What other incredible secrets has nature already figured out for us?